Hi everyone, welcome back. So we're on question 5. I'm going to start reading the problem. It says Reggie's World makes 3 toys that use plastic compound, which he orders from Michigan. Data concerning those products appear below. So we have a table, we're going to need this. There was a major snowstorm in last week, and Reggie's shipment of the plastic compound is stuck in North Dakota. Reggie has 2,000 ounces of the plastic compound in his raw materials warehouse. So that's something important that we want to consider, is that we have a constraint, right? So this is a constraint problem. So the very first question, it asks us to calculate the contribution margin for each product and determine which product is the most profitable when Reggie has his normal supply of the plastic compound and he is able to produce all necessary products to meet demand. So we just want to determine which one's the most profitable, and that kind of even leads into the second problem, which we'll see. So let's start with the contribution margin. So hopefully you guys can see a little bit of this information over here on this side, but if not, you have your version. So we want to start with the unit selling prices. So the selling price for the toy soldiers is $10, and then for the toy horses it's $12, and for the spacemen it's $15. And then we have a variable cost per unit. So this is that right underneath that, the selling price. So $8, $7, and $9. So we know that when we calculate contribution margin, we just have to do the selling price minus the variable cost. So I'm just going to do that really quickly. So we're just going to subtract these out. And I get $2, I get $5, and then I get $6. Okay, so then what we want to do is, not only are we calculating the contribution margin per unit, we actually want to determine the contribution margin per ounce. So that's even slightly different than what we were doing before. So that's listed right here. So I'll just copy those over to my sheet of paper here. So I have 2.5 ounces for the soldier, 2 ounces for the toy horse, and 1 ounce for the spaceman. So hopefully we remember that the next thing that we want to do to determine contribution margin per ounce is that we would just divide contribution margin by the ounces. So that would give me $6 over here on the toy spaceman, $2.50 for the toy horse, and then 80 cents for the toy soldier. So which one's going to be the most profitable? It looks like right now the spaceman is, right? Because even per ounce, they're more profitable. So our next question says if we only have a certain amount, so if we have our constraint, so the 2,000 ounces, how would we rank these essentially to maximize our profitability? So I'm just going to write rank right here, like that. And so we want to look for the highest contribution margin per ounce. So like I said before, that's the spaceman. So I'm going to put 1 right here. And then the next one would be the toy horse. And then the third one would be the toy soldier. So that means I want to start with my toy spaceman, make sure that I get all of my demand met there before I move to the other products, because I'm going to make the most money off this one. The next question says, what other factors should Reggie take into account when deciding which products to produce? And I'm going to pull over my solution because, again, I don't really want to write this all out. So we want to look at the constrained resource, we want to look at the sales mix, and does one product generate more sales than another? So if that's basically like the demand. We also want to think about the relationship with the customer. If I don't produce, am I going to ruin my relationship with my customer? Or do they kind of just don't really care? They'd rather have the higher producing product too. So those are just things we want to take into account. The fourth question, the fourth and final, says that we want to, this is our extra bonus question. I don't know if you're going to have any of those, but that's kind of fun. How many of each product can Reggie make with 2,000 ounces of plastic in his warehouse to maximize his profits? So we have a constraint and we want to maximize the constraint. So we have a total available of 2,000 ounces. Okay, so basically what we want to do is determine on a per unit level how many ounces we'll need. So we're just going to copy that information down from the top. So I'm going to need 2.5 for the toy soldier on a per unit level, and then 2 for the toy horse, and then 1 for the spaceman. So then I'm given some information on my table here. I'm using my highlighter, and it talks about my monthly demand. Oops. So my monthly demand is that. So that's what I'm going to multiply it by to see how much I should start allocating it by. So I have 750 needed or wanted for the toy soldiers, 500 for the toy horses, and 1,000 for the spaceman. So hopefully you can see that what we're doing right now is we're multiplying the ounces needed for each product by the monthly demand to see how much of this 2,000 ounces that we can use for our higher producing products. So this isn't telling me how many units I'm going to make. This is telling me how many ounces I'm going to use. So if I multiply all of these together, I get 1875 needed for the toy soldiers, 1,000 needed for the toy horses, and 1,000 needed for the toy spaceman. So first, as I showed you up here through our rank, I want to start with my toy spaceman because that's our highest producing. So the total that I'd want to make here is 1,000. I want to make all of those. So that would mean that I'd use 1,000 of those 2,000 ounces. And the toy horses are the next one, and I want to make all 500 if I can. And I can because I have 1,000 left, and there's 1,000 ounces that are needed for that. So I would use the 1,000 ounces for that. I don't have anything left now, so I can't make anything for the toy soldiers. So this question asks us how many of each product that we would be able to make. So if we stopped here, we wouldn't have enough information because this just tells us how many ounces that we would use for each of these products. So what I'd need to do is divide back down into the amount of units. So my answer would be I would make 1,000 toy spacemen. That one was kind of easy because you just need 1 ounce for each product. And then for the toy horses, I would divide 1,000 by the ounces needed to get us back at 500. So 500 toy horses. So that's the answer for that one. So I'll come back to you with the next video.